Okay, so factor by grouping again. You're going to group the first two and group the last two. And then you're going to find the GCF for both groups. So the greatest common factor for 27 and 3, the biggest number that divides into both, is 3. So you're going to factor out a 3. Okay, and that's kind of an ugly 3. Let me redo that. And then I take a look at their variables. This one's x to the third, or x times x times x. X to the second is x times x. And I look at what they have in common. They both have x to the second power in common. So I'm going to factor out x to the second power. Okay, so remember you're dividing by that 3x squared. So 27 divided by 3 is 9. And then x to the third taking out x to the second leaves you with that little x right there. Okay, and then 3 divided by 3 is 1, and then x squared, and I'm taking out x squared, leaves me with no x's. Now, if I notice the first sign, it's a negative, so I'm going to factor out that negative. It's always going to be that first sign. The biggest possible number that goes into 18 and 2 is 2. So I'm going to divide out a 2 from both terms. They do not have variables in common. So 18x divided by 2 is 9, and actually it's divided by a negative 2. So negative 18 divided by negative 2 is positive 9x. Negative 2 divided by negative 2 is positive 1. Notice these two match again. That should always happen. So you're going to factor out that matching pair, or that binomial, and factor it from that, factor it from that, and that leaves you with 3x squared minus 2. Now, ask yourself if these are perfect squares, the one that has the exponent. If they are perfect squares, keep going. If not, you're done.